Welcome back, everybody in the room. We're ready for our second session this morning, and the builders promised us to be a little more quiet this part of the morning, so we have high hopes of that. You heard Michael Mabe say in his overview of the STM report how important data is, and we have a special session about that with some excellent speakers. I'm really happy to have the panel here as it is. I'm the moderator of the moderators, so I'll leave it to the real moderator to introduce the panel. But I want to introduce the moderator, of course, is Jerry Greenier of IEEE. Frequent visitors of our STM conferences know him only too well. He used to be the chair of the Future Lab Committee, which is now handed over to Sam Bruinsma, who sits over there. And in his daily life, Jerry is the Director of Publishing Technology at IEEE. Jerry, please lead us into this session.
Well, thank you so much, Evka. Well, good morning again, and welcome back from the MDPI-sponsored coffee break. And for those of you who are doing email here, we can thank for that Adapon Systems for so graciously funding the Wi-Fi access. And welcome also to the students of Christine Borgman's Data Curation and Policy course at UCLA. For those of you who don't, outside of the U.S., UCLA, University of California in Los Angeles, and we are beaming live to them back via Skype. So thank you, and thanks for setting this up. This is a wonderful way to also not miss your students, Christine, and get in a course today. So big data, of course, right, is on the covers of Science, Nature, The Economist, Wired, the front pages of the New York Times, the Wall Street Journal. It seems that we are inundated with stories about big data. And of course, we live in a world now where low-cost sensors and low-cost compute and storage power are driving the collection and processing of data and creating mountains of data by the very researchers that we serve as publishers. So the question becomes, what will the role of publishers be in this world? Will we build subject-specific repositories? Will we peer-review data? Will we lead authors to certified third-party repositories and serve as the matchmaker, if you will, to lead them to places where they can preserve their data forever and ever? Or will we simply be bystanders and stay behind in the paper-only publishing world? Our panel this morning, we're lucky enough to have a great panel this morning that will collectively address these questions, the social, cultural, and technical issues surrounding this great challenge before us. We'll begin with a keynote overview, get a view from a prominent data repository, and wrap up with an effort and hear about an effort to map relationships between articles and related data and artifacts in the world. Kicking off our session today will be Dr. Christine Borgman. Dr. Borgman is professor in the UCLA School of Information Studies. She's the author of MIT Press book, Big Data, Little Data, No Data, Scholarship in a Networked World, and I'm happy to say that when this session ends, copies of Dr. Borgman's book will be available by the registration desk, and we have the pleasure of also getting signed copies today. So I urge you to go to the desk after this session. Copies are available for purchase and signature by the author. So without further ado, to kick things off, Dr. Christine Borgman.
Thank you. Thank you. Thanks, Jerry. Thanks to Evka and Michael Mabe and so on for the invitation. And given what key stakeholders publishers are in the whole movement toward data access, open access, publishing, and so on, it seemed an ideal opportunity to come and address you today. And what Evka and I worked out was, because today is the day that I teach the graduate course in data policy and curation, is we would simply beam my students in, and Peter Darch, our postdoc, who's working working with me on the course is here hosting at the other end and keeping the conversation going all the way around. So I'm not going to give you answers. I'm going to give you more open and very difficult questions that need to be dealt with. And for starters, Michael has already reminded us that this is the 350th anniversary of the first English language journal, and it's changed in many ways and yet surprisingly little. April 19th is the 350th anniversary issue of Philosophical Transactions. I gave a talk at Göttingen a couple of weeks ago, and they brought the original copy out, leather-bound, with white gloves that we got to present at the talk. So how do we get from there to data, where we are now and talking about today? It's a long way and a short way at the same time. This is a set of paired policies around data and publishing from around the world, and they intersect in funny ways. They're never quite setting up, open access to data, open access to publications on the same embargo periods, the same rules. And as Michael said this morning, the difficulty with counting open access policies is because they vary so much in definitions. Even more so with data, you'll find very few of these policies even include a definition of data in them. The Australian one, which I put first, is the only one so far that has put data management into the code for responsible conduct for research. So managing your data well is considered part of data responsibility. This is the tour that I have made, and with a series of grants from National Science Foundation, Sloan, Microsoft, and others, over since about the late 90s, we've been out in the field in a number of different sciences, following people around as they make data, think about releasing it, reusing it, sharing it. And this is where I ended up, is first to frame in the first part of the book the whole problem of how did we get here, what are the provocations, what's at stake, why do we have all these well-motivated policies for release of data. And they have good words in them like reproducibility and reuse and data mining and leveraging public investment and scholarship. But what all those mean on the ground? I devote an entire chapter to what are data, and I'll spend a good bit of time on that today. And then I set up a model of the different kinds of uses of data in different fields in the third and fourth chapter, spend the middle part of the book in a long series of case studies, starting with astronomy and ending with Chinese Buddhist philology. Then the last third, I come back and talk about some of the policy and curation issues. So I'll give you a couple of clips from examples in the middle part. We'll talk about what are data, but mostly we'll think about those releasing, sharing, and some of the stakeholder issues and where publishers fit in as essential partners in where we go from here. So the talk is organized around these 5 points. First, to talk about data, then publications, then a more direct comparison between them, questions of release and sharing and reuse, and then lastly, keeping data useful, as well as keeping publications useful. Okay. So data first. I thought I got over big data a long time ago, but nobody else is really over big data yet. So you have to kind of start by thinking about what are we talking about here? This definition, this three-part one, goes back to 2001. This is the Gartner Group, comes from very, very much a business world, that says data can be big in terms of size, the volume of it, but also the rate at which it comes at you. And in scholarship, it's often the variety, the degree of heterogeneity of the data that is the greatest contribution to complexity. But already you're seeing a lack of agreement on even what those dimensions might be. The long tail is another popular metaphor. This is even more reductionist. It says a few people have a lot of whatever that is, and then more people have only a little bit of whatever that is. Okay, but it gets a sort of a comparison. Open data we hear a lot about, and this is the definition from the Open Data Commons. And if you don't put too much analysis into it, this makes a lot of sense. It's free. It doesn't have a lot of restrictions on it. Anybody can use it. Data's out there to discover. There's a whole lot of buzz about big data, I think, is the assumption. There's massive amounts of data out there just waiting to be discovered, where, in fact, this is what a whole lot of that free open data looks like. Okay. Not very useful, not very structured, not very well marked up. This is the much more complex definition of open data that the OECD promulgated starting in 2007. And this one is really at the other extreme because it says just how complex it is to make data open. If you're going to get something that meets all of these, well, that's probably nigh unto impossible. Someone I showed this slide to said that the intersection of those is the null set. I think that's probably true. Is we've got to decide, are we going to go mostly toward openness? Are we going to be more concerned about who's responsible, more concerned about security, accountability? There's many different things we could think about. But all of those led us back to this fundamental problem of what are data in the first place. When you look at those objects on the screen, what do you see? And you'll see different things depending on what kind of research you're trying to do, what your field is. You might see a model organism. You might see something that is going to run around in a cage. You're going to look at the behavior of it. You might see something, you're going to look at a slide. You might see clinical trials. You might see a facial structure. One of the groups that we're looking at is face-based. It's comparing craniofacial deformities across humans, primates, mice, and zebrafish. Okay, and so very different structural comparisons. I've got some examples of the Pisa Griffin farther down there. That's an object that's been sitting on top of the Pisa Duomo for about 400 years now in plain sight, and they're still trying to decide whether it was made in Spain, Egypt, or Italy. They've traced the metals in it to some particular mines in Cyprus. And then there's a great deal of work going on trying to figure out how it got from one place to the next, whether it's a Christian object, whether it is a Islamic object, or whether it was there to frighten people away as strange sounds blew through it atop the cathedral. So many different things could be data. So this is where I ended up, is to say that data, they're not things, they're not stuff. One person's signal is someone else's noise. Data are in the eye of the beholder. They're representations, and they could be of particular observations, of objects, of different kinds of entity. It's when you use them as evidence of some kind of phenomena. That's when they become data, particularly for research purposes. So kind of hold that thought, and I'll take you through many different examples here. Making useful data. These are two of the areas that we've studied for a long time. First, astronomy, the Sloan Digital Sky Survey, and actually working closely with Tim and the gang at Johns Hopkins on this one. And the second being sensor networks, which Jerry mentioned. We spent 10 years as part of the Center for Embedded Network Sensing, NSF Science and Technology Center. One's sort of canonical big science, the other's more canonical small science. And thinking about how the science gets made, first we have to knock off this Chris Anderson notorious Wired magazine cover from 2008. I think researchers are still feeling the repercussions of this. The claim that now we have all those data out there, we don't need the scientific method, we don't need theory anymore. And in fact, that's certainly not at all what we see when we look at the research process. We find very much that people have models and theories, they start with some research question, and they have elaborate methods that are specific to their domain, but those may continually to be adapted, particularly in these highly collaborative kinds of work. And that's one of the things that Peter has been working on with us, is to see that when you get many different disciplines working together, they influence each other in ways that the methods begin to merge. It's very hard even to categorize methods or data from one discipline to the next. And this enters into how we might describe data and make use of them. So the Sloan survey, this is the telescope that's been getting data since about 2000, and we've been looking mostly at the phase 1 and phase 2 and working with the Johns Hopkins group on trying to curate those data and make them useful for the longer term. Now, these data are released not continuously, but in roughly annual increments, because the time it takes to curate them, to process them, to clean the artifacts, to deal with the calibration. And you can't really mine these all at once. The kind of results is questions more like this one. This is from some of our collaborators at Harvard who are taking pieces of Sloan data, of data from Chand or from many other places and trying to turn them into something you can actually ask a question out of. And there, one of the challenges is that when you take data from multiple places and combine it, and derive new data products, there's often no place to put them back. Okay. Those data we often find to be orphan data and sitting under desks, even in astronomy. Similarly, the work that we've done with the Center for Embedded Network Sensing, and this is one for an entire decade, about 300 people were involved, somewhere between $60 and $100 million worth of funding went into this. Looks like pretty big science, largely computer science and engineering, partnering to find ways to build new instruments to do new kinds of science, whether it was biology, water quality. They were looking for harmful algal blooms, a number of other things, wind tunnels and such. And these data turned out not to be saved much, that they were very much small science in character. The difficulty of developing an instrument to get something new, you end up with very non-standard kinds of data formats that there was no home for and that they had a hard time even keeping themselves. But on the ground, we saw that when these people were working side by side, they had very different notions of what were the data. So some engineering researcher we interviewed was concerned about whether today's temperature measurement matched up to yesterday's or the week before or from one sensor to the next. And to him, temperature is temperature, and that numbers was what he needed to publish in his engineering journals. A biologist on the same project, working side by side, had a very different idea of what exactly were the data coming off those instruments. He couldn't trust them unless he knew exactly how those things were calibrated, how recently, where they were positioned. This is one where he had to line up 3 different instruments for a year and compare them day by day before he could begin to get the amount of calibration, because his reference point, his standards, was to other people in his field and international calibrations around access to data. So similarly with the PISA-Griffin project that I've mentioned once already, is this looks like small science or really even art history, which is where it started, but we've got metallurgists and structural engineers and many other kinds of fields involved in it. They are scanning this object at sub-nano scale. And so they've got many terabytes of data being modeled and managed from this. Okay. So you've got this real crossover of what each group considers data and how they're going to manage them in the short and long term. So what are publications then? Okay. This format looks pretty familiar to most of us. But this networked model, the hub and spoke that you've got is in one of your examples here on the fancy little flyers and notebooks you gave us. This is more what publications are starting to look like, networks, and I know Tim's going to talk about those, and Meredith, I think, somewhat as well, is how do we get all those pieces to come together? This is from an article that we did about 5 years ago with Herbert van de Sompel, one of the originators of the object reuse and exchange. We're trying to figure out how you keep track of all those different things. This was specifically from sensor network research. And as you develop a project, you're in the field, you're writing protocols, you're gathering observations, you're doing your analyses. If you're really going to interpret the data down the line, you need to have some ability to map those and get the relationships between them. And that's where things like object reuse and exchange come along, and it's a later generation that Tim and Jerry and others are dealing with now. You probably can't see the detail. This is from a 2010 paper in Journal of American Society for Information Science and Technology. But we've got details in here about semantic relationships between permission layers, deployment plans, the project wiki, different versions of the data. And we found that was, beautifully, we could tie them together, but it was incredibly handcrafted, much more investment than any of the researchers were willing to make. and the project overall had no resources and expertise to begin to make this kind of investment in making those data useful. Because for as much as we would like to think that this beautiful, neat way of doing research is the case, that you could model this way, in fact, very often research looks more like a random walk. Okay, there's lots of dead ends. People don't do the beautiful pipelines outside of a few areas of biomedical research. They don't keep very good track. We found in areas of bioscience, they have a hard time even getting back to the individual mouse. They're doing well to get back to the cage of mice that represents one particular genetic strain. So on the ground, we find the data are not as cleanly pulled together as one might assume when we start talking about publishing data. So that takes us to the relationships between publications and data. And this is an old idea from rhetoric, and it's one that comes up in science, technology, and medicine, and in science technology studies quite a bit, is to say that publications are much more than containers of data. They're arguments. Okay? And you're laying claims to an idea, you're putting a stake in the ground, and you're getting evidence to support those. And you can use different kinds of evidence to support your argument, and you can use those same sets of data to support different kinds of arguments. So it's not a one-to-one mapping between a publication and a data set. And even more, we find very complex many-to-many relations. And I think this is also where the publishing data metaphor breaks down, where it assumes that one publication equals one data set and you've got a clean match. In fact, people often go out in the field many times to get enough material for one paper, or one trip to the field may have enough for many papers. You may have cumulative data and you're slicing and dicing and crossing it to ask different kinds of questions. At least 10 years ago in SENS, we ran across the concept of the least publishable unit, which is probably rather familiar to all of you. And in that field, it was 4 figures and 1 table would get you a paper. So when they had that much data, then they would move on to the next one. But we're finding that there's a very complex relationship, and it's hard to bring those together. Similarly, to the extent that publications are independent units that you can interpret within the 4 corners of the document, although that's changing pretty quickly, people pretty much know what a journal article is, and the format isn't that different from art history to biosciences. Authorship is negotiated. There's a long history of who gets to be first author, last author, corresponding author, whatever the points of power are in any particular field, where that's all really emergent when it comes to data. These are compound objects that don't have clear boundaries to them. The ownership is a particularly intractable problem. People don't think about who owns the data until a dispute arises. Often it's not all clear. University of California, it turns out, claims ownership of all data from University of California projects. I think that's a little-known fact to researchers, certainly to graduate students. And whether funding agencies claim them, not clear. You get multiple funding agencies, multiple countries, multiple universities involved, and people are just beginning to think about this. There were some early papers in the eScience program out of Britain thinking about it, but it really hasn't gotten very far. And when we get into licensing, it gets even messier. We started asking people about who was the author of their data early on, and it turned out the notion of authorship didn't really resonate much at all for them. Gillian Wallace ended up getting her whole dissertation out of the notion of authorship of data. And we found that attribution seemed to make more sense to them, but it's not, but who you want to attribute depends on what the purpose of that naming is. If you want long-term responsibility, it's probably the PI who's got the stable address. But if you want to get back to the person in the field who collected the data and really understands those data, then it may be the grad students, the postdocs, the others who had their hands on them in some way. This is a list we generated for one of the workshops, one of the first workshops that we did around data citation access, and IFCA has been part of the CoData IXD task force, and I'm one of the co-chairs of it, of trying to figure these things out. And you end up with a Hollywood cast list. I mean, it's even messier than the whole, the contributor. I know a number of journals are trying to get beyond just author and say, who had the idea, who did the data analysis, who did the visualizations, and so on. But when you get down to this level of detail, these are things for which we have not normally given authorship credit for. So we've got to rethink the notion of author, attributor, credit, and so on as we move into data. So I'm among some cadre of people who've been pushing back on the metaphor of data publication or publishing data because it seems to mean so many different things to so many different people. The RDA working group, gone to the last couple of ones of those, is mostly focused on linking a single publication with a single data set. Now, they're trying to work on some other things, but they're trying to work on models to do that. I mean, from strictly linguistically, certainly publishing means to make public, but are we talking about releasing? Are we talking about sharing, linking? What's the unit? Peer review is generally fairly synonymous with publication, certainly in the STM areas, but usually we're not talking about peer review, and nobody has really figured out how one peer reviews data any more than they've really figured out what reproducibility means, which varies hugely from one field to the next. So if we're going to curate, preserve, or steward, we need to think about what those collections look like. And most of the assumptions and models around data curation, linking, and publishing tend to assume that data are getting into some kind of repository. And we're making some technical progress. We've got this research objects for scholarly communication, which was charted a couple of years ago through the World Wide Web Consortium. It's working very actively. This has well-known people like Carol Goebel, Dave DeRohr, Xun Zhao, and others working on it and overlapping. In fact, some of the people from this group are part of this that just came out in January, trying to come up with some technical models and laying out what the responsibility is of publishers, of libraries, of authors, and so on. But even here, it's very specific that the assumption is communities will build repositories, put the data in them, and once they're in repository, then you think about linking. Okay. Which gets us to the larger challenge that RDA is trying to deal with, which is research data sharing without barriers. And that presumes that researchers are going to share their data in the first place. And that turns out to be the most intractable problem of all in most fields. Okay. You can release data in a number of different ways. The astronomy, like Sloan, that we've talked about briefly, has made top-down investments where you might spend a decade, in fact, looking at Sloan, looking at the Large Synoptic Survey Telescope, which we're studying now. They really are spending a decade or more in designing the pipeline. They start with Monte Carlo models of what they might find to decide what to collect and to build the instrument. And then more than half of the $1 billion or so going into the LSST is going into the data management processes and to make these pooled resources for the community. But only a few fields, a large, really big science, large facility fields, are in a position to do this. In most fields, it's much more decentralized, like SENS. It's bottom-up investments, and you're trying to bring them back together later, and that's a much harder problem to do. Then people will do things very informally. They'll post them on websites. They'll put up FTP sites. They'll put things up, say, click here to contact me and ask permission, and then you sign a license that says you won't try to re-identify. You'll use them for non-commercial purposes only. And we also see quite a bit of private sharing on request. So Sloan, when they release things about once a year, historically, and that's true with many of the other large repositories, they release them with a data paper that describes all of the work that was done and it's what you need to know. About 250 people are authors on that data paper. That's how they get credit for their work. Astronomy distinguishes between science papers, instrument papers, and data papers. They have different classifications, and they serve different roles. So when people cite Sloan, they tend to cite those data papers. Those are most highly cited papers. So the paper itself becomes the surrogate for citing the data. At the other sort of canonical end would be the social science surveys, ICPSR, Inter-University Consortium for Political and Social Research, which has had its 50th anniversary. This is very well curated. Again, universities are investing large amounts of money, large sort of bundled subscriptions to it. And once it's in, you can get the data in multiple different statistical formats. You get the code book. It takes something on the order of a year from the time someone submits a data set to where it's fully archived and made available, and then it's available indefinitely. Whereas what we found, and this is a paper that we put out, July 2013, Gillian Wallace, I mentioned, is the first author, where this is the 10 years of SENS research. We found that very little of those data ever made it into repositories. There was a little bit of genomic data that did, the seismology data did because they have a repository, but the rest of it, when they did share, it was privately. And they would have a conversation, make some agreements about the conditions under which they would share it, who would get credit for it, and how much additional work would be done to make it available. And it works. It's not scalable, but it works. And it's something that is a personal relationship, which also lets us distinguish between what sharing, what releasing means, and depositing might mean. Okay. So, but generally, we've got this lack of incentives to release data, and this is what the economists will tell you also, is the labor to document data is considerable. Time that you're spending on writing metadata on provenance is time you're not spending on the next research grant. It's a zero-sum game, and there's not a lot of resources or expertise. And getting people to invest in those data so that someone else they've never heard of can exploit them for reasons they didn't see is also kind of a hard sell from a business model value proposition standpoint. Okay. Scholars cooperate. They also compete with each other. If you can control your own data, you can continue to leverage that for yourself. And then, of course, human subjects data, rare species, and so on has huge confidentiality issues. But we also find a lack of incentives to reuse data. The business literature, you'll get fairly far down beyond the hype before you begin to see people really do spend 60, 70, 80, 90% of their time cleaning those data to make them useful. You don't just pick up somebody else's data set and trust it. You've got to spend a lot of time working with it and dealing with credit, and the licensing issues are really rather, we've got patent thickets, we've got license thickets already around access to data, and I think that's sort of the dark side of the text and data mining is how we're going to bring those together. Keeping them useful is the last part of the themes that I want to pull together today. And that is to think about what we really want to do with these. It's not just a matter of being able to find them. You need to be able to interpret them. At least if you get a journal article and it's in English and it's a format you see, you can identify it, you can read it. If you pick up a data set, you need to know what the software is, you need to know a lot about the protocols, you need to know the models and the assumptions behind it. You would often like to compute upon it in different ways. You might want to combine things from multiple sources. There's a very heavy load about what actual reuse and what the purposes are we're trying to accomplish here, which requires lots of metadata. And that's something that librarians and archivists are good at. It's not something that most scientists are very good at. In fact, what we learned to ask not about metadata, but about things like file names and file structures, because that often is the most elaborate metadata anybody actually is putting on theirs, and whether they can remember what those file name means a year later, once the graduate student has left and gone to another country, is also pretty messy. Similarly, provenance, we're now getting progress on technical standards. The WC3 standards for provenance will let you think about how to bring all those pieces together, but they're guidelines. They're not yet something that is really readily embeddable in technology, but the things like the resource maps and the things that Tim and Jerry are working on, those will try to bring some of those together too. And similarly, how long are we going to keep these things useful? Is it reused by the investigator, by your collaborators? Are you going to subscribe to full library and archival standards where you're going to make these things useful for future generations? Those are other discussions that need to be had with the funding agencies, with publishers, with librarians, with learned societies, and so on, is how much investment we're going to make. Clifford Lynch has been talking about these issues quite a bit lately also, and I think the farther down this line we go, the more the provenance questions are going to be key, because people are not going to trust data unless they know where they came from and all the ways they've been handled on down the line. He gave a talk at the Herrenhausen conference, where we both were a couple of weeks ago in Germany. The Volkswagen Foundation's gotten very interested in this set of issues. And there we were talking about questions of how long you're going to store. Are you going to park data for, say, 5 years and then give it an expiration date? What does that do to the business model for repositories? There's a lot of things up in the air right now that we're just starting to think about. And data curation and stewardship, the kinds of things that we do in libraries and archives. And this is more where the expertise tends to be in the keeping data. The data science world, which is coming from computer science, statistics, business, is along the lines of data wrangling, computation, data cleaning, rather than around metadata, provenance, curation, migration, the kinds of skills that come farther down that life cycle to keep them useful indefinitely. So these kinds of economics and infrastructure issues, these are coming more out of schools of information studies, but not yet in large numbers. There's a few programs like ours that are trying to invest in this set of skills, and getting some of these skills into the publishing industry, I think, would also help build some of those bridges. So it's nice to see these kinds of partnerships that are going on here. So the infrastructure is messy. It looks more like this. This is a project that we did with some of the Sloan funds and National Science Foundation funds of bringing people together to think about knowledge infrastructures and the changing power relationships, the changing technical relationships among people. And it's string and baling wire, it's old technology, and it's new, and it's a lot of people and investments and new kinds of arrangements. So this is the other point that I think we need to think about, and certainly publishers should be thinking with us, is what the economic model looks like. Libraries have been sitting in this common pool resources, but in a in a very changing relationship with publishers as we've gone to more lease models and away from collection models for journals. So that the common pool resources are the ones, say, around the data repositories and libraries where they're getting into this business of somebody's got to put up the funds, someone has to provide the expertise, the long-term commitment. You've got to have some kind of a governance model. That might be a professional society, it might be a university, it might be some partnership with funding agencies. But who's going to decide who pays, who has access, how do you deal with free riders, and so on? There's a whole lot of common pool resource questions to be dealt with. Not much of this is really public goods until you, say, throw it up on a website and put it up and, say, put a CC0 license on it, which was one of the early proposals. But people aren't quite willing to, even if they don't literally and legally own their data, they're not usually willing to just throw it up there. A few people are, but not that many. Not clear whether the subscription model is really wise. That's partly what Michael talked about this morning. If data are going to be reusable, you want like with like. You want similar genomic data together that you can mine and compare in common structural places. You want similar survey data together. To attach individual data sets to journal articles and lock them up in PDF is not really going to do anybody much good. That'll let you follow the trail of this particular article, but it won't get to those larger goals around reproducibility, reusability, mining, trust, provenance, building that kind of map, the kinds of resource models that we need to get. So this is the bigger picture of, I hope we can talk about today. The data repositories themselves are not funded for the most part like libraries and museums and archives. Most of them are funded on 3- and 5-year grants. Okay. Data repositories are themselves going dark, and they're making agreements with each other of who's going to pick them up if one of them goes dark and you pass from one to the next. So we've got whole layers of sustainability issues here. We want to put data in repositories that sustain for the long term. The funding agencies are asking people to keep their data, put them in repositories. The publishers would prefer to link to repositories, but we're not making the investments in those repositories themselves as real memory institutions yet. So what part of this are we going to invest? And also notice that now the open door includes journal article repositories as well as data ones, but Europe has a much larger investment in data repositories than the U.S. does. So this is a very different distribution than what we saw earlier of the journal distribution. So let me wrap up and leave time for our other speakers and more discussion. These are the kinds of high points I've tried to bring, and the takeaway points for today is to think about data not as stuff, not as bright, shiny objects, not as animals, not as paper, not as specimens, not as visualizations, but rather as representation. Something becomes data when you choose to use it as evidence of something. And this is why we get into one person's signal being someone else's noise. We follow people around, we ask them what their data are, and you get these amazingly head-scratching responses. Are you talking about my spreadsheet, my observations in the field, the table that is in the paper? Do you want to cite a cell? Do you want to cite the entire database? What are we talking about here? And every person we interview has a slightly different sense on what are his or her data. Okay. Publications are, we're beginning to think about them as networks of research objects, but continuing to think about them as something that's peer-reviewed, which is how we end up with publishing data being really an oxymoron. That it's not clear what that means. People are using it in many, many different ways. So we've got these different kinds of relationships of what an author means in this environment. We're not sure there's such a thing as an author of data. And we've got to deal with attribution and credit, metadata, and structure if these networks are going to work. Okay. We don't have a lot of incentives to release or reuse. The value proposition, the economists will tell you, Julia Lane gave the closing keynote at this Herrenhausen conference, and that's, I think, the thorniest one is if the funding agencies, if the journals, if the scholarly societies are going to promote data sharing, you've got to bring that full circle for the value proposition and invest on both sides of it if they're going to be useful long term. So we need to invest in repositories, in infrastructure, in expertise, and collectively, I think we need to work through what that value proposition is going to look like. Thank you.
Well, thank you, Christine, for a great 35 minutes.